Lesson 15. This is the lesson covering assumptions and proofs. Lesson 15 you can find in your book starting on page 115. Gives you all kinds of postulates. Basically, they're giving you examples of proofs. A lot of proofs end up repeating the same types of patterns over and over again. Are you all right, Geneva? You looked really frustrated. Now everybody on YouTube knows about it. Are you all right? You just heard the word proofs and that just like killed your day, or was it something else? Pretty much that. Okay, so if you've had geometry, and again, that's kind of fewer and fewer of you all the time, but we've done at least a couple of these, I think, in this class where we talked about doing a two-column proof. I'm not, in this class, in geometry you will, but not in this class, ever going to mess with flowcharts or paragraph proofs, okay, which is really, really good news, right, because flowcharts and paragraph proofs suck. They're the worst. It's the exact same information, but it's a different format, and to that end, it's a little frustrating. Two-column proof, I think, makes the most sense. Oh gosh, if we don't have a marker, this is going to be... try to fix this now. It's not going to. Oh my goodness. Please stop. What is happening? Just, no. Well, I don't know what. Let's see if we can hit pause. All right, let's try this now. All right, so when we're talking about proofs, let's see. Okay, all right, we got something here. We got statements, we got reasons. What's the very first thing that should go on my list? My givens. So we're going to state, you know, the things that they've given me. So like ZW is the angle bisector of angle XZY. So we can start off with that. Okay. So that would go there. We'd list it as a given. Okay. XZ is congruent to YZ. That would go there. We would write given. Okay. My handwriting is going to be really poor. One is that the marker's pretty fat. It's not like, you know, a personal insult to the marker. It's just the way that it is. I think it's beautiful the way that it is, but it's just hard to read it. All right, so what we have to determine, my next suggestion after this is go ahead and put in that information. If it says ZW is the angle bisector of angle XZY, what I'm seeing in here is that those two angles are congruent to each other. Do we see that? Okay. All right. Let's see. And the other thing is they tell me is that XZ is congruent to YZ. Okay? All right. Let's see. Now, I've drawn those two little angles, but really we need to supply more information. We need to supply angle XZW is congruent to angle YZW. Okay? Because although we said ZW is an angle bisector, I haven't stated that those two angles are actually congruent to each other. So that includes, you know, this statement that a bisector, helps if I can spell, divides an angle into two congruent angles. And because space is short, I end up using symbols instead of words to depict that. All right, so far does that make sense? Okay. Now, one of the things you want to be aware of when you start a proof is where is it that I want to end up at? Okay? Where I end up at is everything. It's just like on any given test. You can answer a question, but it may not be the question that's being asked, so you can do all the right work conceivably and still get the wrong answer if you're not winding up where they want you to wind up at. So now I've got all this information. That pretty well follows suit. The next thing, can anybody see what else we know about this? Notice that we're trying to prove that two parts are congruent. In fact, we're trying to prove that XW is congruent to YW. That's what we're trying to prove. Am I trying to prove that the two triangles are congruent? No, but will I need to prove that the two triangles are congruent? Yes. What will my final step be? What will be my final reason? Does anybody know? Okay. If they give me two triangles and they ask me to prove that one part of a triangle is congruent to another part of a triangle, 9 times out of 10, or probably 99 times out of 100, all right, my second to last step is going to be proving that those two triangles are congruent. My very last step, or my very last reason, is CPC-TC. What does CPC-TC stand for? Corresponding parts of congruent triangles are congruent. Very good. So, but before I get there, I had to prove that these two triangles are congruent, correct? All right, in which case I need to know, and I think I gave you guys a video a while back of proving triangles are congruent. We had things like side, angle, side, angle, side, angle, side, 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 angle, 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 side, right? Or any combination of three angles in one side. And so what stays in all of that is that I have to have at least one side, right? Yes? Okay. All right. Does anybody else see anything else in here that we can prove is congruent? Between those two triangles, can anybody see anything in there that we can prove is congruent? Very good. WZ, segment WZ, is congruent to segment WZ. Somebody besides the person who spoke up, can anybody tell me what our reason is there? How do we know that those two are congruent to each other? Do you know? Do you know the reason? Okay. This one is a really common thing, and you need to be able to see this. This works for line segments as well as angles, okay? Where something is shared between two different shapes, all right, it's congruent to itself through the reflexive axiom. Okay? So that allows me, I can put that in there. Now, can I prove that those two triangles are congruent? Yes. Side, angle, side. All right, so triangle, let's say ZWX is congruent to triangle what? Can anybody tell me if I'm using ZWX, right? ZWY. Do we understand that though? Okay, because Z corresponds to Z, W corresponds to W, Y corresponds to X. All right, this is the side, angle, side congruency postulate. Okay, you with me so far? Okay. Now I've proven that these two triangles are congruent. I can now say that XW is congruent to YW through what? CPC-TC. Anybody have any problems with that? Do we understand how we got from the beginning to the end? Okay, the more, this proofs are practice. The more of them that you do, the better that you'll get at it, but it's not a formula to proofs. There's not, this is, you know, if I just do this, I'll get it right every time. Because what it's doing is it's building upon the theorems and the postulates and the rules that you already know. If you don't know those theorems and postulates and don't understand how they work together, you're going to have a really hard time being able to put a proof together. Now, fortunately, there's never so many of these on a test that you're stuck having to do a proof. Okay? Although a lot of the proofs that are on the test are pretty easy, I don't ever see any of them that are more than, like, let's say 4 steps. But most people avoid them at all costs. Okay? Let's see. Let's look at this next one. Statement proof. Oh, sorry, statement reason. Okay. All right, so we know that LM is congruent to ON. Okay. Okay, that's my given. Okay, we know that LM is parallel to ON. Okay, that's a given. Okay, anytime that they talk about parallel lines, I need to start thinking about two parallel lines being cut by a transversal. Okay, if they tell me I have two parallel lines, then I'm looking for things that can be cut by a transversal. And if I have two parallel lines cut by a transversal, then I have things like alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent. So I need to look for instances where that's going to be true because those are probably steps or reasons that I'm going to have. Okay? Now in this, it just wants me to prove that these two triangles are congruent. They go ahead and they told me that LM, okay, is congruent to ON, okay? And they told me that these two lines were parallel, these two lines right here, which means that this line is a transversal, okay? And it helps if you continue those lines out so that you see them as parallel lines with a transversal, because if I don't continue those lines out, I'm just going to see it as two triangles, and I won't, for me personally, it helps to extend those out and see the transversal. Okay? Now, because of that, right, I should have some angles congruent to other angles, correct? Can anybody tell me what angle is going to be congruent to what? Now, keep in mind, right, this is another thing that people struggle with, is that we have to be able to label angles correctly. Okay? We're going to label angles correctly. So if you cannot say, in this case, angle P, all right, the rest of them are fairly independent from each other. All right, so those are kind of okay. All right, but go ahead. Angle what? Angle what? In. Okay, angle in. Angle M. Okay? And you would have been fine if you had said angle ONP is congruent to angle LMP, right? Okay, but we'll keep it short. What's your reasoning there? How do you know that those two things are congruent? You said that angle N is congruent to angle M. Those right there. You're close. The word isn't opposite, it's alternate. Alternate. And the long phrase is, if two parallel lines are cut by a transversal, then their alternate interior angles are congruent. We can shorten it to alternate interior angles theorem. Okay? Okay? Does that work? All right, can anybody give me anything else? Angle what? NPO, okay. It's congruent to angle what? No. If you're doing NPO, and we're talking about alternate, we're seeing that these angles are congruent. Okay, then it's going to be, if you're doing NPO, then you have to do MPL, right? So MPL. Okay, what's your reasoning? No. No. You're saying that this angle right here is congruent to that angle right there, correct? All right. You got to note, this actually has nothing to do with parallel lines. What do we call those angles that are across from each other? When two lines intersect, the angles that are across from each other are called what? No, doesn't start with a T. It starts with a V. a V. Vertical. Vertical what? Vertical angles. Angles are congruent. Okay? Now, there's two different ways that you can go about this. For instance, we don't have any rules for side angle angle or angle angle side, I don't believe. All right. So if you're going to use the vertical angle, you still have to find the third angle. You have two different methods for using that third angle. For instance, this is well, let's use a different color. This is another transversal, and so these would also be alternate interior angles. So you could say that they're alternate interior angles and put that up there, or we could say that they are congruent because if two angles, then three angles, right? We've proven two angles, and that's kind of the shorter thing to say. So we could say angle L is congruent to angle O, by saying, and this is the shorthand for that, two angles, then three angles. Okay, but like I said, you could have used the same rule that you used for angle N being congruent to angle M. Okay, now can I prove that these two triangles are congruent? Okay, so triangle what? Let's use what they actually asked me to do. Okay, LPM is congruent to triangle OPN through what? What did we use? Angle, 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 side, congruency postulate. Now this is not the only way to have gotten here. For instance, they told me that this side was congruent to this side. I could have done just those two angles and had angle, side, angle. Right? I could have, if I had kept the vertical angles out of it and just done my two alternate interior angles, right, that would have saved me a step. So my point is this, is that we still got the right answer. And the way that we did it, we had to do those steps. Okay? Because we threw in vertical angles, we had to get a third angle in there somehow. Okay? So it's just practice. So sometimes you can use more steps, sometimes you can use fewer steps and still get the same right answer. Okay? Do we understand number 2? Hopefully. Okay? All right. That brings us down to number 3. Number 3. Number 3 gives you something that looks like a trapezoid. A lot of times they'll take something like this and there's more visual there than what you really need. There's visual components there that are meant to confuse you, to give you more to look at than what is necessary. Okay? So I got my statement, got my reason. Okay, let's look at it real quick. We want to prove that two triangles are congruent. Now, I probably want to figure out which two triangles I'm actually trying to get here. It looks like XFW and YFZ. All right, so did I actually need this line or that line? Probably not. There's probably parts to that that are really just seeking to mess me up. Okay, but as you'll notice in here, I've already got something that's pretty handy, because we saw it in our last question, is that right there, right? We've already used that. You're going to see that a lot. It won't be used in every question, but as often as I see it, I can use it. So once I get practiced enough to see vertical angles, I can use them just about every time I see them. You follow me? All right, so look for things that you can use over and over again. All right, we know that WF is congruent to ZF. Why is that? Because it's given. All right, so WF is congruent to ZF. So we got that right there. We know that XF is congruent to YF. Given. Yeah. I mean, some of these are just one-step deals, right? XF, YF. So what's the only thing I need to prove that those two triangles are congruent? The vertical angles, right? So, but we got to be specific. It's congruent to what? ZFY. Good. You guys are picking up on the fact that I've got to maintain corresponding angles. So we're going to say vertical angles are congruent, which gives me that angle and that angle. Now can I prove that those two triangles are congruent? Okay, XFW is congruent to triangle YFZ through what? Side angle side congruency postulate. So talking about those congruency postulates now becomes really important because I can't just make it up. It has to be those things, right? And if I know that I have those things, proofs are really just kind of like having a mathematical toolbox, right? If you know how to use the tools that are in that toolbox, it makes the job a lot easier. But you can't use everything that's in there, right? You have to know which tools I can use and where I can use them at, okay? I know in the real world, you know, every tool is a hammer, but in proofs, it doesn't always work that way. Okay, are we good with this one? Okay. All right. Let's see. We've got 4, 5, 6, and 7. I think that you probably want to look at 5 and 6. I know we could do 4, but 4 is going to follow some similarities to number 2. As you can see, it's a similar picture. It's not the same proof. They give me different sets of information, so I don't solve it exactly the same way. But the reason I think that you probably want to see 5 and 6 is because if you look at your homework, they're in your homework. Okay? Pretty much the exact same question. They are. So, my guess is if you had to pick two, you'd probably pick those two, right? No? Okay. All right, so AC is congruent to BC, given. All right, CD is perpendicular to AB. All right. When I see two triangles and I've got perpendicular, that means I've got a right angle, and if I've got right angles, I've got, with my right triangles, I get a whole different set of triangular congruency postulates, things like hypotenuse leg, leg angle, leg. I feel like there's another one in there, but probably hypotenuse angle, but all right, and this is given. Okay, so let's put our information in here. We know AC is congruent to BC. We know that that's a right angle, but we're going to be. We know that they're perpendicular lines, but this is the difficult thing about proofs is that we sometimes will skip a step because we know it, but we do have to state it. Okay, we get to the point where we infer. All right, so we do have to make this statement, and that is that angle CDA and angle CDB. Sorry, not angle. Well, yeah, it'd be angle, not here. I need to. Okay, angle CDA and angle CDB, okay, are right angles, okay? And this is kind of a long, wordy deal, but perpendicular lines intersect to form right angles, okay? And because of that, triangle CDA and triangle CDB, okay, are right triangles. Okay, because triangles with right angles are right triangles. We already knew that, right? But I have to say that. That's, some of them are really, really easy and some of them are ridiculous because we know these things, but we have to say these things. Okay? Okay? All right. Let's see. At this point, let's see. We already got our givens. We know that these are right angles. Okay? And when we're dealing with right triangles and we say things like leg angle or hypotenuse angle, that has to be an acute angle. It can't be the right angle. Okay? What else do we know about these two triangles? We've seen this on our very first question of this. They share something. What do they share? Not angle. No, they don't share angle C. Segment CD. Very good. CD is congruent to CD. Okay, what's our reason on that? Reflexive axiom. Okay, so that allows me to do this. Now what I have is I have hypotenuse leg. Okay, so we can say triangle CDA is congruent to triangle CDB through the hypotenuse leg congruency postulate. Okay, I can't use the right angle as hypotenuse angle. It has to be an acute angle. Okay, we get that okay? You look like a southern woman back there fanning herself. You all right? Okay. All right. Hopefully we got that one down. Did we? Okay. No? Okay. All right. Six will be the last one we try to do. I would have given you time to work, and we probably would have had time to work if the smart board had not been going nuts. Okay. All right. Let's see. This one, besides our givens, has has 4 steps. We might be able to do, I don't know if we can do a step less than that or not. All right, so we've got AB, segment BD bisects angle CAD, given. Okay. AB bisects angle CBD, given. Okay. All right, we've seen this. Again, this is kind of reusing. You can go back to, I think, probably question number 1. We saw this in question number 1, right, where we had a segment that bisected an angle. What did we say about that? Well, I would say here that angle CBA is congruent to what? Angle DBA. Why could I say that? Go back, if you took down any notes for question number 1, you would know. Right? A bisector divides an angle into 2 congruent angles. Right? It gives me this and this. All right, can I use that same thing again? Yeah. All right, to say angle what? CAB. Okay. With what? Okay. And for sake of time and effort, it's the same reason, right? Bisector divides an angle into two congruent angles. Same thing. So now I have this angle and that angle. All right. I still need one more piece to prove that these triangles are congruent, though. Emmanuel, do you have it? Oh. All right, David.
If you have two angles of a triangle, then you have all three angles.
Yeah, but angle, angle, angle is not a congruency postulate. Right, AB is a shared side. Okay. We got our reflexive axiom then, because it's a shared side. Okay, which gives me that. Now, do I need my third angle? I do. Yeah, there is. Yeah. There's an angle side angle. There's just no angle angle side. All right? And there's no angle side side. Okay? All right. So we can prove now triangle A. So you have to know those congruency postulates. Otherwise, you don't know when to stop. Okay? So we're going to do angle side angle congruency postulate. Does anybody feel totally lost? Yes? Okay. It's practice, practice, practice. It's getting you used to seeing what it is that you can do. All right, looking down here, can anybody tell me? I mean, I automatically see something in there that I can do. Can anybody? In number 7, how many of you see something that's already in there? There's nothing being said about parallel lines. Okay, that's good though. That's good because it looks similar to that other one that we used. Emmanuel, I think I heard it here too. What? Transversal, that's if these two lines are parallel, and we don't know that because if I look through here, I can see that certain lines are congruent, but I heard Ashley say it. Vertical angles are congruent, right? ACB and probably BCD are going to be congruent to each other because they're vertical, right? And if I have, and I can real quick just look at this, AC is congruent to DC, and BC is congruent to EC, then that's probably the only thing I need in there, right? Because that would give me side angle side, right? That number 7 should be a really easy, quick one to solve. In the end, though, am I trying to prove that, is my last step proving that those two triangles are congruent?
Yes. No.
No. What's my last step?
Minus angle A is congruent.
Right, and what is going to be my reason for that? It's an acronym. C, P, C, T, C. So I can tell you that my last two steps are first, these two triangles are congruent, and I can tell it's going to be side angle side, congruency postulate. My last one is angle A is congruent to angle D through CPCTC. Okay, all I've got to do is write it down.